Okay, this is the continuation, page 3 of Algebra 2 Notes, section 1.1. And we're going to practice the stuff we learned on page 2 with set builder notation and interval notation. And we also have the graphical presentation of that. So what I have here on this first example is a graph where I have a solid dot at -3 and it's shaded in between -3 and +1. The +1 is not included in the graph. So what you're going to do is tell me that the x values on this graph, the shaded part of the graph, is between, you use two less than signs when you do this, -3 on the low end and +1 on the upper end. It also includes the -3 but not the 1. Then you simply put some fancy stuff around this to make it, instead of the notation you were used to in elementary and junior high and Algebra 1, you make it set builder notation by putting set braces around it. That's the first part of it. And I have to leave a little bit of room here because I'm going to tell you that the variable that we're using is x. And then you put the such that line. So it reads like this: the set of all x values such that the x's are between -3 and 1, including the -3. Then when you come over here to interval notation, you tell me the start and the end of that set. It starts at -3 and ends at 1. And then you tell me whether it includes these endpoints. Well, you can see by the solid dot that it includes the 3, so you could put the square style around that. And it does not include the 1, so you put the round style on that end. So this is the interval notation version of the same thing. These all mean the exact same thing. So here I want the set of all x values with this condition. Your x values have to be less than or equal to 4. So I'm going to put a solid dot at 4, and I'm going to shade on the line. These have to be shaded on the line, and shade the arrowhead. And that's what the graphical representation of that looks like. Then I look over here, it goes forever to the left. The way we express that in interval notation is -infinity, and it ends at 4. So it starts at -infinity on the left and goes all the way to 4. -infinity and +infinity are slippery. You can't actually get there, so you always have to use a round parenthesis with that one. But since we're including this 4, you can see it says or equal to there. You have to use a square bracket on that one. Okay, so this one is similar to that one. We're going from -infinity all the way up to 2. So we're going to include the 2 because of the square bracket. And we're going from -infinity, which is on the left, all the way up to 2. And you always want to go from left to right, from left to right, from left to right when you put these down. So -infinity belongs on the left, and 2, belongs on the right. So the way you express this in the other format is you first of all do the fancy stuff. We're moving in the horizontal direction, so it's x. There will be times when I do y here. And these are the numbers that are less than or equal to 2. So all of the stuff, including the red stuff I put around it, is set builder notation. Okay, one possibility here is that you're going to have a set of all numbers, all real numbers. And it's the whole number line that gets shaded. And since this goes forever to the right, in other words towards infinity, and forever to the left, you shade these arrowheads. Remember, all your shading, your circles, and your filled in circles and your open circles, they all have to be directly on the number line. A lot of teachers teach that wrong. And so what we do here in this case is it's all the way from -infinity clear over to +infinity, and you always get rounded ones with that. Now, the set builder version of this is a little more challenging. So what you do is you say the set of all x's, and you obviously can't list these. It doesn't have a bound, and you're not going to say between negative infinity and positive infinity like we did up here with those numbers. You have to describe it. X is a real number. Any real number. Later in Algebra 2, you're going to learn numbers that are called complex numbers or imaginary numbers. And those are new ones that you haven't learned yet. But the real numbers are all decimals and fractions and positives and negatives and the number 0. Now that's a lot to write down. So the other way of doing the set builder version of this filled in number line is to simply say all the numbers, and the symbol you use is an R with 2 backbones. So you go like that and you make the letter R out of it. And that is the same thing as this. So you can either write it out like that for set builder notation, or you can just use a symbol for all real numbers. And then when you get over here to interval notation, it's from negative infinity to positive infinity. Okay, moving on to another concept, domain and range. And this is a little slippery too. This book is quite a bit harder than our previous books, but they're upping the game, and you're going to have a better education because of it. The set of all possible input values, all of the x values, okay? That set is called the domain of the function. So all of the x values in a big pile that are actually on the graph are the domain of the graph. So we'll do that in a minute, but let me explain what the other direction is. If you're telling me all the possible y values or output values, that's called the range. So all of the x values, which is right and left on our graph, that's the domain. And all the y values you see on the graph, that's the range. So we're going to start with the domain, the x values on this graph. And you can see that if you're over here, you're on the left side of the graph. So these x values are all negative. When you get to here, the x is 0. That would be approximately 0, 1.5 or something like that. And the x values are getting bigger as I go over here until I get to an x value of 3, and then it turns back again. Now, we learned earlier that this is not a function because it doesn't pass the vertical line test, but we'll answer that in a minute. What I'm interested in here is, what are the x values that are actually part of this graph? Well, certainly it never gets over to x equals 5. There's no graph over here on the right, 5 to the right. It doesn't have any x values over here near 4. So the furthest it gets is 3, and all these x values to the left of 3. So the domain here are the x values that are to the left of 3, less than 3, or equal to 3. Now you want to put this in set builder notation. And sometimes I'll ask you to put it in the other version also. And this is forever to the left, negative infinity. And when you get over here, you're at 3. It does include the 3, square bracket, but it does not include the other one. So there's 2 ways of doing this. The first way is called set builder notation, and the other is interval notation. So that's the domain. We put a D there for domain. Is this a function? Well, let me see. Vertical line test, hit twice, not a function. If you draw any vertical line and it hits more than once, so I had lots of places I could have drawn that line to show that this fails. For instance, I could have drawn that line over here and it would hit up here and down there. And as soon as it crosses more than once on a vertical line, it's not a function. Okay, to illustrate the range, which is the output values or the y values, I'm going to switch to this graph down here. The collection of all the y values is what we're looking for. Now if you look at this graph, it goes forever downwards, okay? But it does not go forever upwards. In fact, the highest place it gets to is 3 here, and you can see that it says 1, 3 there, so I know that this thing is the y values that are less than or equal to 3. So that'll be the range of this one. The question here actually is what is the domain and the range of this one. So let's go in order. First, the domain. You can see this arrowhead here, and what you need to know about that arrowhead is the general direction it's heading, it continues. So that means this goes forever downwards, which most people would guess, but it also means, since you're going to the right at the end of that arrow, that it goes forever to the right. Likewise over here, this is forever downwards, it's also forever to the left. And for domain, where we're interested in the x value, it goes forever to right, forever left, and everywhere in between. So this is all real numbers for the domain. The x values get bigger and bigger and bigger, or smaller and smaller and smaller as you go from right to left and back, okay? The other version of this we had earlier, it's up here in this box. The interval notation version is that one. So the domain of this one is all the way from negative infinity to positive infinity. Now when you switch gears and you're talking about the range, now you're talking about up and down. And this time it's y values you're interested in, so it'll look like this. The y values such that the y's are less than or equal to 3. You can see that these y values are getting lower and lower and lower, numbers that are smaller than or equal to 3. And then you finish it off with that other set brace. And then the way this works is you're going at the bottom at negative infinity, and you go all the way up until you top out at 3. You always want your smaller value on the left. Now because we actually get up to 3, and it's part of the range here, you're going to include it by putting a square bracket. And that concludes page 3 of the notes for section 1.1.